Hello everyone, let's go ahead and get started on 16 and see how you did. We have a negative 4.8, a negative 4.08, and a negative 4 1/8. So we need to make sure that all of these are decimals. Right now we have this fraction that's 1/8 and we need to convert that to a decimal. At this point, I don't think we can use mental math. I don't see an easy way to make this 8 into a 10 or a 100. So we're just going to have to do the long division. 1 divided by 8. So I'm going to do that right here. 1 divided by 8. Can 8 go into 1? No, it cannot. We add the decimal. We add a 0. Can 8 go into 10? Yes, it can. It can go in 1 time. 1 times 8 is 8. 10 take away 8 is 2. And then we add a 0. We drop it down. 8 goes into 20 2 times. 2 times 8 is 16. And then we do the subtraction. 10 take away, we have to borrow from the 2, making that a 1. 10 take away 6 is 4. 1 take away 1 is 0. We still have a remainder, so we have to drop down another 0. And now we have, does 8 go into 40? Yes, it does. How many times? It goes in 5 times, and 5 times 8 is 40. And now we have no remainder. So that's what we have. It's going to end up being a, well, that's not much of a different color. This is going to be negative 4.125, okay? So we have negative 4.8, we have negative 4.08, and negative 4.125. So I'm going to go ahead and do a number line here. So if I have this being 0, and this would be positive 1, I'm going to make these ones. Okay, so this would be negative 1, negative 2, negative 3, negative 4, and I'm going to just make that bigger gap because all of these numbers are between negative 4 and negative 5. And I'm just going to do them divided into 10 spots. So 1, 2, 3, 4, 5, 6, 7, 8, 9, right there. So negative 4, that's 0. So it's going to be very, very close to negative 4.1. This is negative 4.1. And so negative 4.08 would be right before that, right there. And then negative 4.125, okay, would be right after the 4.1. So this one would be right here, and this one would be right here. And then negative 4.8 would be, this would be 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8 would be right here. Okay? So remember, these are least and to greatest. So it would be negative 4.8 would be the least. And then it would be, then the green one, that would be next, and then this is the greatest one right here, just because the way that negative numbers are. So, yeah, we're going to have negative 4.8, that's the least, and then negative 4.125, which is the same thing as negative 4 1/8, and then the greatest one in this group would be negative 4.08. All right. So that's number 16. Let's go ahead and try 17. What I notice about this, we have a positive 5.78, we have a negative 5 7/8, and we have a negative 5.9. So right off the bat, these two are negative, this one's positive, we know this is the greatest. So we just need to figure out what's going on between these two. This is a decimal, this is not. So we need to go ahead and convert this into a decimal. I don't really see a really easy way to make this into a 10 or 100, so we're just going to have to do the long division. So 7 divided by 8. Does 8 go into 7? No, it does not. I'm going to add a 0 here. 8 goes into 7. Oh, decimal goes there. 8 goes into 70 8 times. 8 times 8 is 64. Then we're going to do we have to borrow, make that a 6. 10 take away 4 is 6. Again, we have a remainder, so I'm going to add a 0 and drop it down. 8 goes into 67 times. 7 times 8 would be 56. Have to borrow again, make that a 5. That would be a 10. 10 to take away 4. 6 is 4. Add a 0, drop it down. Then we have 48 goes into 45 times. Okay, so that's what the answer is to that one. So we have a positive 5.78, and then we have a negative 5. 7/8 is the same thing as 0.875, and then we have a negative 5.9. So I'm going to go ahead and make a number line here. All right. This is 0. 1, 2, 3, 4, 5. Okay. So we know that this one right here is greater than 5. So it's going to be, you know, over there. Bigger than 5. A little bit. Closer to 6. And then we have negative 1, negative 2, negative 3, negative 4, negative 5, and then negative 6. I'm drawing a space. I know that that's not consistent with these other ones, but this is where these two numbers are. So I'm just going to divide it into 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this one right here, negative 5.875. So that would be negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8. And it's a little bit past negative 8. It's really close to 0.9, but it's not quite there yet. And then negative 5.9 would be 1, 2, 3, 4, 5, 6, 7, 8, 9. It would be right on that line. So those are really, really close together, but this one ends up being the least, and this one is in the middle. Okay, so we end up with the least would be negative 5.9, negative 5.875, and positive 5.78 would be the order for those. All right, great. Let's move on to this next problem right here. 6/7, 5, 6, and 0.8. Okay? So let's go ahead and convert these into decimals. With the 7 and the 6 on the bottom, I don't see either of those becoming a 10 or 100 very easily. So we're just going to do the long division. So we're going to go 6 divided by 7 first. So 6 divided by 7. 7 doesn't go into 6. I mean, it goes in 0 times it. Okay, so that's, I'm going to add here. 7 goes, oh shoot, I didn't mean to do that. Let me just start over. Okay, 6 divided by 7. Okay, 7 does not go into 6, so we add the 0. 7 goes into 60. That would be, how many times? 8. 8 times 7 is 56. Okay, so then we need to borrow. We have a remainder of 4, that's a 5. And then we add a 0 and drop that down. 7 goes into 40 5 times. 5 times 7 is 35. And then we have there we go, right there. That's a 3. We have a remainder, so we drop down another 0. here. 7 goes into 50 7 times. 7 times 7 is 49. Then there's a remainder of 1. We have to drop down another 0. 7 goes into 7 one time. 1 times 7 is 7. And 10 minus 7 is 3. And then we still have a remainder. We're going to drop it down again. 7 goes into 30. How many times? 4. And 4 times 7 is 28. And we have a remainder of 2. I think at this point, we're just going to kind of leave it like that. So, because it just looks like it's going to keep going. Yeah. So, remainder 2. Okay, so 6/7 is the same thing as 0. Let's round it to the nearest thousandth. So 8, that's tenths, hundredths, thousandths. That 1 does not round it up, so it stays as 0.857. Okay, so that is 6/7. So the next one we need to do is 5/6. So that is 5 divided by 6. So 6 does not go into 5. So we add the decimal. 6 goes into 50. How many times? 8. 6 times 8 is 48. 6 times 8 is 48. We subtract, and there's 2. We have a remainder, so we need to add the 0 and drop it down. 6 goes into 20 3 times. 3 times 6 is 18. And then we get 2, and it looks like this is going to become repeating. Yeah, it's going to become repeating, and so on. So this 5/6 is actually the same thing as, I'm going to write it down here, 0.83 repeating. And then we have 0.8. So one of the rules that it says is, hey, just, you know, make them all. So this has, what does this have? This has 3 decimal places here. 3 decimal places. We need to make this 3 decimal places, which would just be 833. And then this 0.8, just need 2 zeros to have it be 3 decimal places. So we're looking at the numbers 857, 833, and 800. Those numbers right there. So I think it's pretty obvious that 800 is the smallest number, and 800 is the 0.8. And then which number is next? The 833, which is the 5/6, followed by the 857, which is the 6/7. And there we go. That's from least to greatest. Yeah, I would look at these numbers if I was doing it. If I had 0.8, 0.857, and 0, I'm just going to put 0.83. So they all have a 0. They all have an 8. Where they have it, the difference is in the hundredths place. This is a 0. So I would look at that. I would look at the hundredths place. This is a 0 here. The hundredths place here is a 5, and the hundredths place here is a 3. So I know 0 is the smallest number. I know 5 is the biggest, and 3 is the one in the middle. So this would be the smallest, this would be the next one, and then that would be the largest. So by looking at the decimals, that's how I would determine that one. Okay, so hopefully you got this one right. Let's move on to 19. Okay. Problem number 19, we have 2 2/3, 2.65, and 2.69. So the first thing we have to do is convert this fraction into a decimal. I don't see an easy way to make this a 10 or a 100, so we're just going to have to do the long division. So it's 2 divided by 3, 2 divided by 3. Does 3 go into 2. No, it does not. So we add a decimal here and a decimal here. Okay, does 3 go into 20? Yes, it does. How many times? It goes in 6 times. 6 times 3 is 18. And then, you know, we drop, we have a remainder 2, so we add another 0. 3 goes into 20 6 times. This looks like it's going to be a pattern. Yes, it is. So the answer to this one is just repeating 6. So this is 2.6 repeating. And then these are decimals, which are nice. Now what I notice is that these have 2 decimals, these have 2 decimals. This one's repeating, so I'm just going to add another decimal onto it. Now when I'm looking at all of these, what I see is they all have a 2, 2, 2. They all have a 6, 6, 6. They're all positive. So that where the difference comes is with the thousandths place. And so I have 6, 5, and 9, and I see that 5 is the smallest number, so that means that 2.65 is going to be the least. 6 is the next biggest number, so the next one is going to be 2, and this is represented by this, 2 2/3. And then the biggest one is 9, so it's going to be 2.69. So there you go. That's how you would put those in order from least to greatest. Okay, let's move on to 20. 20, they're all negative numbers. We have a decimal, decimal, and 3/8. So yeah, like I said before, it is not easy to put 8 and make it a 10 or a 100. So we have to do the division. So we're going to go 3 divided by 8. 8 does not go into 3. And so 8 goes into 30... How many times? 3. 3 times 8 is 24. And then we have to borrow. That becomes a 2. 10 take away 4 is 6. 2 take away 2 is 0. We have a remainder, so we need to add another 0 and drop it down. 8 goes into 60 7 times. 7 times 8 is 56. And then we have to borrow. 10 take away 6 is 4. We have a remainder, so we have to add another 0. And then 8 goes into 40 5 times. 5 times 8 is 40. And we take away right there, no remainder, so we know we're done. So there we go. We have negative 3/8 is the same thing as negative 0.375. So we have 0.38. We have negative 0.375. And we have negative 0.04. Okay. So, with the negative numbers, I'm just going to go ahead and make a number line. Yeah. So I'm going to make a number line. This is going to be 0. And then instead of making it in increments of 1, I'm going to make it in increments of 0.1. So this is going to be 0.1. This is going to be negative 0.1, negative 0.2, negative 0.3. So negative 0.3. And then this is going to be negative 0.4. All right. So if we have negative 0.04, it's just like, it's not even 0.1. It's closer. This would be right here. If I did half there, half of 0.1 would be negative 0.05. So I would say negative 0.4 is going to be really close to that. So that's where negative 0.04 would be, right about there. If we did one of these, 0.38, well, we have 0.3. If I made this into increments of 10 in here, so 1, 2, 3, 4, 5, 6, 7, 8, 9. 0.8 would be here, right? Right there, and then 0.375 would just be a little bit right there. So you can see that 0.38 would be the least. This one would be the one in the middle, and that one would be the greatest. So that's just what we're going to write. So the answer would be negative 0.38. And then the one in the middle is negative 0.375, which is negative 3/8. And then we have negative 0.04. So that is from least to greatest. Okay, on to the last one of these type, 21. We have 3/7 and 0.45 and 4/9. So the first thing we're going to do is do the long division here. Like I said, with 7 and 9, there's no easy mental math there. So we just have to do the long division. So that's going to be 3 divided by 7. 7 goes into 3. It does not. So we have to add 0. 7 goes into 30 4 times. 4 times 7 is 28. And then that's going to be a remainder of 2. We add the 0, drop it down. 7 goes into 22 times. 2 times 7 is 14. We have a remainder of 6. And so we got to drop down another 0 here. 7 goes into 60 about 8 times. 8 times 7 is 56. 56, 56. And there's a remainder of 4. I think I'm just going to leave it as 0.428 for right now. We'll just leave it there. Okay, so that's what that equals. And then we know 0.45. Now we just need to figure out 4/9. So I'm going to go 4 divided by 9. Does 9 go into 4? No, it doesn't. Add a 0. 9, does it go into 40? Yes, it does. It goes in, how many times? It goes in 4 times. 4 times 9 is 36. And that's going to be a remainder of 4. And then we're going to add a 0. And 9 goes into 40 4 times. 4 times 9 is 36. And we have a remainder of 4 again. So this is going to be a repeating decimal here. So we have the decimals 0.428, 0.44, and 0.45. So here, since they're all positive, we have 3 decimal places here. We have 1, 2 here, but this one's repeating. So I can just add another 4, and now we have 3 here. And then 0.45, it has 2, but if I add a 0, then it has 3 decimal places. And one way it talks in the book is just, hey, forget about the decimals and just call it 428, 444, and 450. So when we look at this, we know that this right here is the smallest, which is 0.428, which is 3/7. So 3/7 is the smallest, followed by 0.44444, which it would be 4/9, and 0.45 is the biggest. And so there we go. There's our answers. Now, if I was looking at this, I look at they all have a 0, they all have a 4. Where they're different is right here in the hundredths place. So 2, 4, 5. I know that 2 is the smallest out of those, so that's why that's going to be the smallest. 4 is smaller than 5, so that's going to be in the middle, and this one is the biggest number, so it's going to be there. So that's how you tell just by looking at the decimals. All right, perfect. So we are on to these next 2 story problems. I want you to try them on your own first, and then come back and check your answers. So go ahead, press pause, work them out, and then press play and come back. Okay, we're back. Let's go over 22 and 23. It says 24 karat gold is considered pure. So 24 karat gold, it's like nothing but gold, it's pure. If a ring is 14 karat gold, what is the purity as a fraction as its decimal rounded to the nearest thousandth? So we need a decimal, and it needs to be to the nearest thousandth. So when it's talking about purity, what we would have is, we know that 24 is totally pure, and 14 means it is partially pure. So that's really our fraction. It's going to be 14 over 24. So to figure that out, I don't think we can use mental math. This isn't going to turn into 100 or a 10 really easily. So we're just going to have to do the long division. So it's going to be 14 divided by 24. Okay, does 24 go into 14? No, it doesn't. I'm going to do the long division, but one way I'm going to make this easier on myself is I'm going to reduce this fraction first. I know that 2 goes into both of those. So 2 goes into 14 7 times, and 2 goes into 24 12 times. So I'm really going to be looking at 7 twelfths, and I don't think there's any common factors between there. And so I'm going to do the long division here because it's going to be easier than doing 14 divided by 24. Okay, so 7 divided by 12. Does 12 go into 7? No, it does not. Does 12 go into 70? Yes, it does. It goes in 5 times. And 5 times 12 is 5 times 2 is 10. And I carry the 1. 5 times 1 is 5 plus 1 is 60. So then I subtract, and I get 7 minus 6, which is 1. I have a remainder, so I'm going to drop down this 0. Okay, I know that 12 goes into 100 about, let's see here, maybe 8 times? I'm going to go do it over here. 12 times 8. What is that? That is 8 times 2 is 16. 8 times 1 is 8 plus 1 is 9. So yeah, 96. So yeah, 12 goes in there 8 times. 8 times 12 is 96. I go ahead and subtract, and it's a remainder of 4. There's a remainder, so I got to drop down the 0. 12 goes into 40 3 times. 3 times 12 is 36. And 40 take away 36 is going to be 4. And so I think it's going to become repeating after that point. So it's going to be I see a pattern emerging. So 0.58333. Now it says round to the nearest thousandth. So this is the nearest tenth, hundredth, thousandth right there. So I'm going to look to the number to the right, and that is not a 5 or above. So our answer is just going to stay right there. So our answer is going to be 0.583. So if a ring is 14 karat gold, what is the purity as a fraction and as a decimal rounded to the nearest tenth? So I'm going to say this is to the nearest thousandth. So this is a decimal, and the fraction would be 7 twelfths. So that would be the answer to that one. If you got that one right, great job. Make sure you simplify that and you don't write it as 14/24. It needs to be simplified to 7 twelfths. Okay. Let's go on to the next one, 23. It states that Amy scored 9.02 on her balance beam routine. Joella scored 9.2 on her balance beam routine. Which gymnast received the highest score? So we have 9.02 and we have 9.2. Now, if I was doing this, I see that both of them have a 9. That's the same. But here, there's a difference between the 0 and the 2. Okay? So I would just be looking at those numbers, and since they're both positive, I see that this is a smaller number and this is bigger. So that means this is the smallest score. So which gymnast received the higher score? It would be the one that got a 9.2, which would be Joella. Joella scored a higher score. Now, with the book talked about looking at these and then just basically looking at the decimal places. So there's 2 decimal places here. There's 1 decimal place there, so we need to add a 0 so that there's 2 decimal places. and then it said just ignore them completely, and you have 902 and 920, and which is a bigger number? Well, this one is a bigger number, which is Joella's. So that's just another way of finding the answer. So I just wanted to show you both ways. I mean, we've been talking about both ways throughout this entire assignment, and it's always good to be able to know how to do things in a variety of ways. So, all right, great job, and we will see you next time.